Have you ever played a game and was surprised by the AI? Some enemies just feel smarter. It all comes down to how developers combine different AI systems. In this video, we are going to look at a really powerful combination: finite state machines and behavior trees. I'll explain how they work together to create AI that feels truly alive. And we'll even talk about how you can start thinking about implementing this yourself. Let's start with a fundamental question. Why can't we just stick with one AI system? Finite state machines have been the backbone of game AI for decades. And for good reason. They're simple, predictable, and incredibly efficient. But here's the problem. Finite state machines are inherently rigid. They struggle with complex decision making because they can only consider their current state and immediate triggers. Imagine trying to create a realistic NPC merchant using only a finite state machine. You'd need separate states for every possible interaction. Behavior trees emerge as a solution to finite state machine limitations. Instead of rigid states, they use a tree structure where the AI continuously evaluates conditions and selects appropriate behaviors. They excel at complex decision making and can handle multiple factors simultaneously. But behavior trees have their own problems. They can be overkill for simple behaviors, they're more computationally expensive, and they can become incredibly complex to debug when something goes wrong. Here's what actually happens in professional game development. You rarely use just one system. The most sophisticated AI in modern games uses hybrid approaches, and that's exactly what we're going to explore. So how do you combine these systems effectively? The key is understanding what each system does best and use them in complementary ways. Think of it like a layered cake. At the bottom, you have finite state machines handling basic state management. On top of that, you have behavior trees handling the complex decision making within those states. So when the finite state machine says I'm in combat, the behavior tree takes over and decides should I advance, retreat, flank, use a special ability or call for backup. The magic happens in how these systems talk to each other. The finite state machine can set variables that the behavior tree reads, and the behavior tree can trigger state changes in the finite state machine. For example, a behavior tree might be evaluating combat tactics, realize the AI is heavily damaged, and trigger the finite state machine to transition from combat to retreat state. Once in retreat state, a different behavior tree or different branch takes over to handle retreat behaviors. Let's look at how this works in practice, starting with the NPC system in Cyberpunk 2077. Night City is filled with hundreds of NPCs, each needing to feel alive without crushing your CPU. The base layer uses finite state machines for fundamental states. Once a state is selected, a behavior tree takes over. Enemy AI behavior trees dictate decisions like choosing cover based on visibility and distance, flanking when in squads, calling reinforcements or throwing grenades. After patch 2.0, enemies move more dynamic, break line of sight, suppress the player, and use cover intelligently. Civilian AI use simple finite state machines and have states like idle, panic, or flee. Pathfinding is nav mesh based and uses waypoints. Before patch 2.0, police would just teleport behind the player. They used hard-coded spawn logic and not real path finding. After patch 2.0, police AI uses a heat map notoriety system, similar to GTA. They now pursue the player both in vehicles and on foot, use cover and coordinate more like combat units. Spider-Man's combat system showcases how hybrid AI creates dynamic, challenging encounters that scale with complexity. Let's start with basic thugs. Their finite state machines might have states like patrol, investigate, alert, combat, stunt, defeated. In combat state, a relatively simple behavior tree handles tactics. Can I hit Spider-Man with a melee attack? Should I shoot at him? Is it too close or too far? Are my allies in good positions? But then you have enemies like the Senator's 6 bosses. Their finite state machines have more states: Phase 1, Phase 2, Phase 3, Special Attack Mode, Vulnerable. Within each phase, sophisticated behavior trees manage complex behaviors, analyzing Spider-Man's recent attack patterns, coordinating with other enemies, managing special abilities and cooldowns, adapting to environmental factors, and responding to player skill level. One of Spider-Man's standout features is how enemies use the environment. This is perfect for behavior trees because it requires evaluating multiple factors. What objects can I throw? Can I use elevations to my advantage? Should I destroy the structure to limit Spider-Man's movement? Or are there civilians I need to avoid hitting? The finite state machine ensures enemies are in the right state to make these decisions, while the behavior tree handles the complex environmental analysis. The Witcher 3's monster AI represents some of the most sophisticated creature behavior in gaming, and it's a masterclass in hybrid AI systems. Every monster in The Witcher 3 uses a similar finite state machine foundation. But what makes each monster unique is how their behavior trees operate within these states. Let's examine a griffin encounter. In hunting state, the griffin's behavior tree evaluates Gerald's position and movement, available aerial attack vectors, ground-based attack opportunities, whether to use wind attacks, environmental factors like nearby trees or cliffs, and its own health and stamina. The finite state machine ensures the griffin is in the right behavioral mode, while the behavior tree creates those dynamic, unpredictable encounters where the creature feels truly intelligent. Here's where it gets really impressive. The behavior trees include environmental awareness that makes monsters feel like they belong in their ecosystems. A forest griffin behaves differently from a mountain griffin, not just in stats, but in tactics. Forest griffins might use dense foliage for surprise attacks, while mountain griffins use elevation and wind currents. The finite state machine states are the same, but the behavior tree decision making adapts to the environment. Alright, let's get into the practical stuff. How do you actually do this in Unreal Engine? Epic's made it pretty easy with a system called State Tree. Basically, it lets you break down your AI's behavior into different states, and then within each of those states, you can add all sorts of smarts to control exactly what your AI does. We'll dive deeper into this in the next video, but it's really a powerful way to build believable AI. Ultimately, it's not about finding the perfect AI system. It's about finding the right combination of systems. And that is what we're seeing in games like Cyberpunk 2077, Spider-Man, and The Witcher. If you found this useful, let me know in the comments. See you in the next one.